and welcome to class again. So today we're dealing with SS3 second week's topic, logarithms and indices. Now, if you are lacking the foundation, the basics for logarithms, and how to use your logarithm table, I recommend that you watch our SS1 and SS2 videos on logarithms. But in this particular class, we'll be dealing more with our logarithmic equations and general questions of logarithms. Same with indices. And so on the board here I have with me certain laws that I would love you to take note of on logarithms and the laws of indices. Now we have the 7 laws of indices clearly stated here, and we have the laws of logarithm and the relationship between indices and logarithm, and also a few things I would love us to take note of, which will be helpful in solving logarithmic questions. So you have this generally known law, you have this one, where when you add the logarithm together, you multiply this, and when you subtract it from each other, you divide. Now you have this law operates more when you are dealing with the powers of logarithms. It operates when you are dealing with the powers of logarithms. And also when you have this law, this is actually the relationship between indices and logarithms. We also have this law of logarithms here, and this one is one thing you should take note of whenever you see logarithmic equations that involves whole numbers, just whole numbers. This one will really come in handy. And also when you see indices questions that involves whole numbers like just 1 or 2, most times this one actually comes in handy. Now let's get to solving questions. Here we have questions on logarithms, and here we have questions on indices. So we'll be solving 3 questions each for both sides. Now, look at this question. Most likely you will encounter questions like this. If log 10 power h power 2 is what? 0.3010, and log base 10 power 3 is what? 0.4771. Find the value of log base 10 raised to power 4.5. It's quite simple. Now, all we have to do is look for the combination of how we can get 2 and 3 to give you 4.5. Whether combination of multiplication and division, how do you multiply and divide each one, any one, to give you 4.5. Now 4.5 is actually 45 over over 10, right? Now if you break this down, 5 here will give us 9, 5 here will give us 2. So it's actually 9 over 2, and 9 is 3 square. Now we have something we can work with, right? Now this is actually equals to 4.5, right? Good. Do take notes. Now replacing log 4.5, log base 10 raised to power 4.5, now be log base 10 this power 4.5 is no longer there. We now replace it with 9 abi 9 over over 2, and the square of 9 is 3 raised to power 2 abi over 2. Now this bit over here means they are dividing each other, right? Good. Now I said something about our logarithms. I said that the laws of logarithms and indices can be read either forward or backwards. I've said it in like SS1 class, I've said it in like SS2 classes before, that the laws of logarithms can be read either forward or backwards. And if you remember the laws that say that log a plus log b is equals to log ab, right? And the one that says log a minus log b is equals to log a over b. Now, is this one we'll be taking note of? We'll be applying it here now. You have log 3 square. Now this log 3 square over 2, you can say the same thing as log 3 square minus log 2. If you take this in the reverse, if you take it backwards, this is what you will get. And now, random law of logarithm that states that what? Log a raised power b, not b, this is not the base value, a raised power b is equals to b times log what? A. Now if you apply it here, you now have what? This one will become what? 2 log 3, 2 times log 3 minus log 2. Now what do we do after I've gotten this kind of value? We simply substitute these 2 here. Now this will give us what? 2 times what? 0.4771 minus what? 0.3010. And 2 times this will actually give us 0.9542 minus 0.3010, which will be equals to what now? 0.9542 minus 0.3010. Subtract 2 minus 0, 2, 4 minus 1, 3, 5 minus 0, 5, 9 minus 3, 6, and you have your 0. So this gives us what? 0.6532 as our final answer. And that is that for this question. Very quickly, let's go to the second question. But before I go to the next question, I will recommend that you go back in this same class, this same video, and pause the class from the beginning. The laws I wrote out on this side of the board and on this side of the board, get a piece of paper and write them down beside you as we solve. And you can also pause the video and do what? And attempt the questions yourself, especially if you have been to class before. If you have been to a class where you've been taught this before, you can pause our videos and do well to practice yourself before you play again, so that you can what? You can check if you are getting it right. Okay, looking at this one now. I once recommended creating a chart in SS1 video on indices. Please do well to watch that video where I showed my SS1 students how to create their charts. Now that chart will be helpful for you when you are dealing with questions on indices. For example, you easily know that the cube root of 125 is 5 and the square root of 25 is also 5. The goal of questions like this is to make all of them have the same base number raised to different powers, and then you can start easily applying the law of what? Indices. Now if you apply the law of indices well, you have what? 5 times what? Convert this one now to 5 raised to power something, because the three of them can have a common base number of 5. A common base number of 5. Now 25 is actually what? 5 raised to power 2, right? Okay, so when we substitute it, we can now have 5 raised to power 2 raised to power what? X plus 1. Now, like I told you before, that's your chart that you have copied, that's your laws that you have copied down will come in handy now. If you remember, there's a law that connects both of them like this. When you remove this bracket, you multiply this by this. Okay, and you have is equals to what? 125 is actually equals to 5 raised to power 3. If you follow that video where I taught on indices for SS1, you will use that chart and you'll be able to easily discover the roots of numbers down to even the 6th and 7th roots of numbers. Okay, now you replace this one with what? 5 raised to power 3, like this. Okay, we are close to getting our answer now. And what do? Let's deal with this bracket first. Let's deal with this bracket first. You have 5 times 5 raised to power what? 2x plus 1. Now, this one is not only multiplying x, it's also multiplying x plus 1. So you put it like this, and you have 5 raised to power what? 3 times x will give us what? 3x. Okay, now 5 times 5 raised to power what? 2x plus 2 is equal to 5 raised to power what? 3x. We are close to our answer. What do we do now? We combine both together. How do we combine them? The first law of indices that says that what? This will now be equal to what? 5 raised to power what? This same base, and and you add the powers together. Now this one has an invisible power of what? Of 1. An invisible power of 1 times, sorry, not times now, plus, we are adding the powers together, plus 2x plus 2 is equals to 5 raised to the power 3x. Now collect like terms here. You have 5 raised to the power what? 1 plus 2 is what? 3 plus 2x is equals to 5 raised to the power what? 3x. Now this can cancel this. Now we bring the powers down and we have 3 plus 2x equals to 3x. Collect like terms, 2x goes to the other side. You have 3 equals to what? 3x minus 2x. So our x is equals to what? 3. And that's our solution for the first questions. Like I said earlier, before we get to the answers, you can pause the video at any point and solve for yourself.